is the 45, 45, 90 triangle. That is an isosceles triangle, okay? Like I just showed you on that last problem, if we know the lengths of the two sides are the same, it's isosceles, which means the two base angles are the same also. So we're going to call this, for instance, x, x, and y, okay? The way that we set that up is we would say x squared plus x squared equals y squared, right? It's Pythagorean theorem. Now, for our purposes, for what we're going to do in this chapter, I feel like people often get x confused with, like, x in the broad sense versus this side length is x. So I don't use x and y. Your book might show you, like, x is the length of a side and x rad 2. I'm not going to use those, okay? I'm going to use L for legs and H for hypotenuse because it just gets confused less. So if you want to leave it as x and y on that one, that's fine. I'm going to show you on the next one in terms of L what they'll look like. But let's just say this is a leg, this is a leg, and this is a hypotenuse, okay? Same thing as I just showed you right here. It would be L squared plus L squared equals the hypotenuse squared. And that would be true for every single isosceles 45, 45, 90 triangle, okay? If we simplify this, for the third time today, L squared plus L squared is what? 2L squared, not L to the fourth. So I get 2L squared equals H squared. If I want to know what H is, I'm going to take the square root of both of these sides. So I'm going to square root here, and I'm going to square root here. This is just going to be H. What's the square root of L squared? It's L, okay? So we can take the square root of this. We cannot take the square root of 2, so we're going to leave it as rad 2. That means that my hypotenuse here, I could take the H out of it and put in L rad 2, okay? Which means if this is our triangle, leg, leg, and then that third side is the leg times rad 2, okay? So let's just set it up in terms of L's here. If this is a leg in a 45, 45, 90, then this side will always equal L rad 2, okay? Meaning if this leg had a length of 2, then this hypotenuse would be 2 rad 2, right? If this leg had a length of 4, then my hypotenuse would be 4 rad 2. It will always be the length of the leg times rad 2, okay? So we're going to use that idea. I'm going to ditch these numbers so I'm not confusing you. We're going to use this concept basically just as a shortcut, because here's the thing, guys. In a 45, 45, 90, Pythagorean theorem will always work. You can always use the Pythagorean theorem if you don't remember the shortcuts I tell you right now. I don't recommend it because it's going to take you 3 times as long, because the way I'm going to show you right now is going to be like, you can get an answer like that versus all that work to get your answer. But you can always use the Pythagorean theorem, okay? So if you need a, what's it called? Fail-safe? Pythagorean theorem, okay? But let me show you a better way. Uh-oh. Oh, there we go. Sorry, my screen froze for a minute. So let's look at this first one. It says solve for the value of each variable. Now, we know that our sides in a 45, 45, 90 are L, L, and L rad 2, right? What is x?
8.
It's 8, right? Your legs are always going to be the same. So x is 8. Can you tell me what y is? 8 rad 2. It's the length of a leg times rad 2. So y is 8 rad 2. Okay, so if they give you a leg, please don't do the Pythagorean theorem. That should be super easy. 8, 8, 8 rad 2 every single time. Okay? What if they give you a hypotenuse instead? So this second one here, They tell us that the hypotenuse is 5 rad 2. Can you tell me what x and y are? It's 5, right? If it's L, L, and L rad 2, L has to be 5. Does that make sense? Okay, that's about as easy as they get. Sometimes they'll give you those. That's beautiful. That's great. Awesome. This next batch is where it gets a little more challenging, but I'm actually going to give you a shortcut to my shortcut. Fancy, right? And if you can remember that, these ones don't take any work at all. If you can't remember it, then it takes a little bit of work to solve these. But if you can remember the shortcut to the shortcut, you're in a real good spot. Okay, so here's what I need you to look at. In this one up here, they told us the hypotenuse was something times rad 2, which means that something is our leg, which is a number that's already there for you. On this one, they don't tell us the hypotenuse is something times rad 2. They just tell us here's the length of the hypotenuse. But we know that this hypotenuse is the same as L rad 2. So that's what we're going to do. We're going to set it equal to L rad 2, and we're going to solve for L, and that will give us the length of our two legs. Okay, so this is a 45, 45, 90, and we're going to solve this equation. 10 equals L rad 2. Now, get your algebra brain out. How do you solve for L?
You square both sides.
We're not going to square both sides.
Oh, darn.
But a lot of times when there's a radical, that's what we end up doing. But we're not on this, because it would actually make our problem more complex. How do you get L by itself? You divide, right? We're going to divide by rad 2 on both sides. So this is 1, which means not changing our answer. L equals. Now on the left, we have 10 divided by rad 2. Do you remember the rules with radicals? You cannot have a radical where? On the bottom. You cannot have a radical as a denominator, okay? So to get that out of there, we have to rationalize it. Do you remember rationalizing these problems? We're going to multiply by something that won't change the value, but it will change the look of it. Anyone remember it?
Reciprocal.
Not the reciprocal. It's a good guess. We did that a lot. We want to multiply by 1, but 1's not going to look like 1. It's going to look like rad 2 over rad 2, right? That's not going to change our value because we're essentially multiplying by 1, but it is going to get the radical out of there. So on top, we have 10 rad 2. What's rad 2 times rad 2? Rad 4, which is 2, right? So we get this. Is that a simplified answer?
No.
What is that?
10 rad 2, 2.
Which equals?
5 rad 2.
5 rad 2, right? We got to divide this. So this is 5 rad 2. So the length of our leg is 5 rad 2. Okay? That's fancy, but I'm going to give you a way to do that much quicker. Okay? Hold that thought. Hold that thought. Okay, look at this one. I know the hypotenuse in a 45, 45, 90 triangle is equal to what in terms of L? L rad 2, right? So we're going to do the same thing that we did on this one. We're going to say 14 equals L rad 2. Okay? We're going to solve that. Divide by rad 2 on both sides. That goes away. Multiply by rad 2 over rad 2 on both. Okay? So 14 rad 2 on top. What's rad 2 times rad 2? Rad 4, which is 2, right? Whenever you multiply a radical by itself, it's just the radicand. It's the number under the radical, okay? That simplifies to 7 rad 2. So x and y up here are 7 rad 2. Oops. Okay, x and y are both 7 rad 2. So now here's what I want you to see. Jason saw it already. Anybody else see it? The shortcut to the shortcut?
Oh, you just
It was 10. Now it's 5 rad 2. It was 14. Now it's 7 rad 2. You cut it in half and you multiply by rad 2. And that will give you your leg. Okay, so here's the rule. If they give you a 45, 45, 90, and they tell you this is 18, to find your legs, you're going to cut it in half and multiply by rad 2. So what would this be? 11 rad 2. Isn't that beautiful? Okay, does anyone see the hiccup? Where is there a problem? What happens if it's odd? Okay. So if it's an odd number, we don't like decimals with radicals because it's just not pretty. It's not simple. So instead, let's say this is 19, okay? As long as you understand what you're doing, this one's easy too. You're cutting it in half and you're multiplying by rad 2. That means we're going to go cut in half, multiply by rad 2. So your answer is just 19 rad 2 divided by 2. Okay? That's boring.
Yeah.
I mean, you can solve for it. You can... No decimals. We don't do decimals here. Because it's not like the pure answer. No, decimals are not pure. Not like whole numbers are. Okay, anyway. Any questions on that? Okay, so I feel like all of this on its own, they're rather simple ideas. It's just that now there's several different things that all look very similar, but you do slightly differently. So just be careful with that if you're given a leg, your hypotenuse is the leg times rad 2. If you're given a hypotenuse, you're going to divide by 2 and multiply by rad 2, right? So there's all this rad 2 times 2 divided by 2. What are we doing? Keep it straight. If you can't keep it straight, what are you going to do? The Pythagorean theorem, okay? When in doubt, you may always use the Pythagorean theorem on these, okay? Okay, last problem. In a courtyard shaped like a square with a 250-foot long side, what's the distance from one corner to the other? So we're looking for this length, okay? Real world problem, what do? We round, right? We don't want radicals on the real world problems. So if this is our setup, first of all, what type of triangle is this? It's a right triangle, but it's also a 45, 45, 90 because we just cut a square in half, okay? So in this 45, 45, 90, what is the value of x? 250 rad 2. But like I said, we don't want 250 rad 2. We want a decimal answer on this one because it's real world. So you're going to plug it in. 250 times the square root of 2, and it comes out to something. What? That comes out to 353.6 feet. Okay? Questions on that?